Hello my dear students, how are you? I hope you are doing well and keeping yourself in a good state of health. I welcome all of you on this educational platform, and on this platform today I shall discuss the chapter Some Basic Concepts of Chemistry. Let me tell you students, this is very important chapter and a basic fundamental of chemistry. If you ask me, some basic concepts of chemistry is not a chapter. It is indulged in the every single chapter of chemistry. So it is definitely a basic fundamental unit of chemistry. So let's discuss this chapter further. Let's come and let's study.
In the chapter Some Basic Concepts of Chemistry, the first point which we shall discuss is the mole concept. Now the point is, what is mole and what is the requirement of mole? Let me give you a very simple example. Suppose you have two students in front of you, student A and student B. Now if I ask you a very simple question that which one is taller, then your answer, it will be very easy for you to give the answer of this question, as it is clearly visible that A is taller than B, right? So when I asked this question, you gave the reply that A is taller than B. Now suppose I asked you another question, that A is how much taller than B, or in terms of the value, it is how much percentage taller than B. Now you cannot answer this question just by watching A and B. Now all you have to do is measure the length of A and B as well. And for doing this, you would be needing units. So basically in this physical world, we need units for the sake of measurement. So how many type of units we have, guys? We have two kind of units. Number one is the basic units, or you can say the fundamental units, and number two are the derived units. Derived units are so many, but basic units are only 7. These are those units which cannot be divided further, and these basic units together they constitute the derived units. So which are the 7 basic units? Is the mass. Number one is mass, time, length, electric current, temperature, and also intensity of light. And the last one, but not the least, is mole. So mass, kilogram is the unit of mass, time for unit is second, length is meter, electric current is in ampere, temperature is in Kelvin, intensity of light is in candela. What about the mole? What mole measures? Mole measures the amount of substance. It is the unit of amount of substance. So we measure the amount of substance in terms of mole, right? Do you understand what is the amount of substance? Amount is how much amount of substance you are talking about. See, we define the amount, that is in local methods also. Suppose someday I am feeling thirsty and I told you that please get me 1 glass of water. So what I want to drink is water. And how much water? 1 glass. So this 1 glass specifically is the amount of water. But in science, we do not define the amount in such terms like 1 glass, 1 tablespoon, or such units. Here we use the scientific unit. So rather than saying 1 glass or 1 teaspoon or half cup, I will say 1 mole. So you will understand the exact amount which I want you to understand when I will say 1 mole or half mole or similar like that. So what concepts we shall discuss in this class? My dear students, in this class we will discuss about the introduction, then we will discuss about the atomic mass, then we shall discuss about the molar mass, we will discuss about the mole concept and the basic important formulas of the mole concept along with the Avogadro's number, right? So these are the concepts we will gonna study in this class. So let's proceed further. First is atomic mass. Now in the 19th century, scientists adopted a comparative method to find the atomic mass. So it is calculated in terms of the comparison. Suppose now, say for example, you go somewhere, any railway station or any other place, you saw a weighing machine over there, okay, and you go to the weighing machine and you weighted your weight, and suppose it comes 50 kilogram. Now suppose machine says that your mass is 50 kilogram. What does it mean scientifically? If mass of any person is 50 kg, what does it mean? Students, it simply means that particular person is 50 times heavier than mass of 1 kilogram. So he is 50 times heavy than the mass of 1 kg. So basically what you are doing, you are calculating his mass in comparison to the 1 kilogram. Similarly, for the sake of atoms, we find out the atomic mass in comparison to the other atoms, say hydrogen being the lightest. Now we know that hydrogen atom is the lightest element. Now we assigned the mass of hydrogen as 1 without any units. So it is believed, it is supposed that mass of hydrogen is 1. And the other elements were assigned the mass relative to the hydrogen. Suppose if I say that mass of calcium is 40, which simply means that mass of one atom of calcium, that one atom of calcium is 40 times heavier than the mass of one atom of hydrogen. Similarly, in the present days, the present system which we use here is the atomic mass is based upon the carbon-12. Guys, you must be knowing that carbon is having two kind of isotopes, carbon-12 and carbon-14. So this system, present system which we use nowadays, it is based upon the atomic mass of carbon-12. And it simply says, see, what is the mass of carbon-12 is 12. And what about the 1/12 of the 12 is 1. So 1/12 of the part of carbon-12, 1/12 of the part of carbon-12 is considered as 1 AMU. 1/12 of 12 is 1. So that is called as 1 AMU. AMU is atomic mass unit. Nowadays, this atomic mass unit is also called as unified mass. So nowadays, rather than saying 1 AMU, sometimes in book you will see 1 U, and the word U means unified mass. So this is all about the atomic mass. So what is atomic mass? How can we define the atomic mass? In the definition, atomic mass of an atom is the number that compares the mass of given atom with the 1/12 of the carbon-12 atom. Or in terms of the formula, you say atomic mass is mass of an atom divided by carbon-12 atom into 1/12. And 1/12 of the one carbon atom, that is carbon-12, is 1 AMU or 1 U, as I told you, unified mass. So this is how we calculate the atomic mass. Now what is atomic mass unit? AMU. One atomic mass unit is defined as the mass exactly equal to the 1/12 of the mass of one carbon-12 atom. You got it, students? it is exactly equal to the 1 by 12 of the mass of one carbon 12 atom. Say for example, 1 AMU is 1.66056 into 10 to the power minus 24 gram, or 10 to the power minus 27 kilogram. And mass of the hydrogen atom is this much. Mass of a single atom of hydrogen is this much. So if I ask you what is the mass of hydrogen atom in terms of AMU, what is the mass of hydrogen atom in terms of AMU? It will be 1.6736 divided by mass of 1 AMU. It will come 1.0078 AMU, which you can nearly say after round off 1.008 AMU. So this is the mass of one atom of hydrogen in terms of AMU. 1.008, this is the value, right? Now here it comes the molar mass. Like we studied about the atomic mass, now it is time to discuss about the molar mass. What is molar mass? Molar mass is the mass of 1 mole of the substance in grams. Suppose if I ask you what is the molar mass of sodium chloride? What is the molar mass of sodium chloride? So it will be equal to the sum of the mass of their component. Now what are the components of NaCl? In the NaCl components are sodium and chlorine. So mass of sodium is 23 atomic mass, and the mass of chlorine is 35.5, which is average of the isotopes of chlorine. So finally it comes 58.5. So this 58.5 gram is the molar mass of NaCl, which simply means that 1 mole of NaCl will be equal, 1 mole of NaCl will be equal to 58.5 grams. Please note. Now here comes the mole. So as I told you, in the SI system, that is System Internationalis, a mole is the base quantity for the amount of substance. So we use the mole to define what? We use the meter to define length. We use the second to define time. We use the Kelvin to define temperature. Similarly, we use the mole to define the amount of substance. So 1 mole is the amount of substance that contain as many particles or entities as there are atoms exactly in 12 gram of carbon 12. So whatever the number of atoms which are present in 12 gram of carbon 12, because 12 gram of carbon 12 is 1 mole. 12 gram of carbon 12 is 1 mole. So whatever the number present in 1 gram of carbon 12 is equal to the number of particles present in 1 mole. Any other substance which contains the same number of particles or ions or molecules or the entities which are equal, any entity which is equal to the 12 gram of carbon 12 isotope is considered as 1 mole amount. So simply 1 mole is given mass of carbon 12 divided by the 1.992648 into 10 to the power minus 23, that is the mass per carbon atom, carbon 12. After calculation of this, you get the value 1 mole is 6.023 into 10 to the power 23 atoms per mole, which is also called as Avogadro's number, which will later we will see in this unit. So how big is a mole? What do you mean by dozen? Guys, if I ask you, what do you mean by dozen? What is dozen? 1 dozen is 12. What? Anything. You say 1 dozen students, I'll say 12 students. You say 1 dozen banana, I will say 12 banana. You will say 1 dozen chairs, I'll say 12 chairs. Similarly, you say 1 mole. 1 mole is equals to 6.023 into 10 to the power 23. This is a huge number, my dear students. Huge number. So these particles may be atom If I say 1 mole atom, it means this much atom. If I say 1 mole molecule, it is this much molecule. If I say 1 mole ion, it is this much number of ions. So in simple words, you can understand that 1 mole is equals to Na. That's it. 1 mole is equals to Na. What is Na? 6.023 into 10 to the power 23. For the sake of numerical calculations, we will consider this value 6 into 10 to the power 23 in the approximations for the numericals. But precisely it is 6.023 into 10 to the power 23. Alright. So what is Avogadro's number? Avogadro's number, I told you, the number of particles in 1 mole of substance is known as the Avogadro number. Now that doesn't matter what kind of substance is this, whether it is an element or it is a compound. If it is an element, no problem. 1 mole means any number of elements. If it is a compound, no problem. 1 mole means any particles of compound. So the actual number of particles in 1 mole is 6.023 into 10 raised to power 23. This is called as Na, number of Avogadro, given by the scientist Avogadro. So the relationship between the gram atomic weight and the Avogadro's number for some common element is, for carbon it is mass of 1 mole is 12 gram. For sodium it is 23. For magnesium it is 24. For bromine it is 80. But the number of particles are same in each case. You can understand, suppose I say 1 dozen chair. I say 1 dozen mango. I say 1 dozen students. Definitely they will not have same mass. 1 dozen chair will be not equal to the mass of 1 dozen mango. But what about the number? What about the number of content? It is 12 here, 12 here, and 12 here. So whatever the species you are talking about in 1 dozen, number will be equal to 12. Similarly, whatever the mass of 1 mole of any substance or element, but number will be same. 6 into 10 to the power 23. So like I say, 1 mole, 1 dozen chairs is 12 chair. 1 dozen mango is 12 mango. 1 dozen student is 12 students. I can say 1 mole atom is Na atom. I can say 1 mole molecules is equals to Na molecule. I can say 1 mole ions is equals to Na ions, right? And these are some important formula which we use for the calculation of mole. Students, 1 mole is equal to 6 into 10 to the power 23 atoms, or 1 mole is equal to 6 into 10 to the power 23 molecules. So in short, you can say that 1 mole is equal to 6 into 10 to the power 23 units. Which units? Anything. These units may be atom, maybe molecule, or the ion. And what is the mass of 1 mole? The mass of 1 mole is the gram atomic mass. It is gram atomic mass. It is the mass of 1 mole. 1 mole is also equal to 22.4 liter volume at NTP. NTP is the normal temperature and pressure. But this NTP, this formulation that 1 mole is equals to 22.4 liter volume is valid only for gas. This is valid only for gas. See, these formulas are unconditional. They are valid for liquid, solid, and gas, all of them. But this is valid only and only for gas. So now I say 1 mole substance. 1 mole substance will always occupy the volume 22.4 liter at NTP. If you have 1 mole substance, its volume will be 22.4 liter. That's for sure. That's for sure. right? So I want you to remember this always. So what is the formula? We can say finally, number of atoms in W gram of an element. Suppose you have any element whose given mass is W. How many atoms are there? So first you calculate the mole. How you will calculate the mole? Mole will be equal to the mole will be equal to the given mass upon the atomic mass. When you do this, given mass upon atomic mass, you will get mole. And when you multiply the mole with the Avogadro's number, you will get the number of atoms. Similarly, if you want to calculate the number of molecule rather than atom, now if you want to calculate the number of molecule, again, first you have to calculate the number of moles, which is equal to the given mass upon, instead of atomic mass, now I will say gram molecular mass. And in the same fashion, we will multiply it with the Na, Avogadro's number. So I can say in short that number of particle is equals to mole into Na. When I say particle, I cover atom, molecule, ion, all of them. Now suppose if you want to calculate the mole with the number of molecules given, so what is the mole? It is X. X is number of given molecule divided by Avogadro's number. And this is how you calculate the molecules. This is how you calculate the number of molecules present in n number of moles. In 1 mole there are Na particle, in n mole there are Na into Avogadro's number, n into Avogadro's number. This much particles are there. This is the number of mole in terms of weight. It is given mass upon molar mass. It is in terms of the weight in grams of n mole. It is number of mole upon molar mass. And this is volume of n mole of gas at NTP. Now this formula is valid only for gas and not always, only at NTP. You can apply the same formula for the number of ions. Like I told you, when I say number of particles, it covers atom, molecule, ion, all of them. Here is one question for you students. Now 1 Avogadro's number represent number of atoms in what? In 12 gram of carbon, 320 gram of sulfur, 32 gram of oxygen and 12.7 gram of iodine. So Avogadro number is exactly the same number which are present in 12 gram of carbon 12. So answer of this question will be option number 1. Now another question. 1 mole of H2O corresponds to which of the following? 1 mole of water. 1 mole of water is equals to what? 22.4 liter at 1 atm and 25 degrees Celsius? No, because it is valid only for gases. Water is not gas, it is liquid. 1 mole of water is equals to 1 gram? No, not at all. 1 mole of water is equals to 18 gram? Yes, because molar mass of water is 18. So the students, 1 mole of water, 1 mole of H2O is equal to 18 gram. This is the right answer. So these were some calculations we did today about the mole, and these are the basic formulas of mole. You should always keep in your mind that mole is something very important and it is indulged in every single unit of chemistry. So these are the formulas we studied today, and we will keep on using these formula in the further lectures. Alright students, good luck to you and keep studying.